Hi everyone, my name is Abel Grey Cantoma, and on this video I'm going to be showing you how to design your base. We have done our design on slab, on our beam, our column, all in our phones. Amazing, right? Amazing. Using our phone to do our design. Wow. So if you don't have a laptop, you don't need to go break the bank, okay? But it's important to get one for yourself, okay? Because you still have a limitation. Maybe when you want to design, when you want to do your detailing on AutoCAD, you can't detail on AutoCAD with your phone, okay? You can only have a CAD viewer. Now to design our base, okay, look at this. You see, as we all know, there are different types of foundation, both shallow and deep foundations, okay. We have pad foundation, strip, raft, pile, okay. Types of buildings. Now we have good soils, okay. We have average soils, we have poor soils, we have bad soil. Now if you are within the metropolis of Kaduna, or you are in Kaduna state, some part of Abuja, Niger, Nasarawa, some part of the state, the soil bearing capacity are always above 100, which is a good soil, okay. And then in Lagos, most especially the island, okay, you can have a lot of bad soils there, and then poor soils, okay, that falls within the range of 40 to 75, or some even below 40 kilonewton per meter square. Now in cases where you have a good soil, mostly we use pad foundations and strip foundations, okay. And in cases where you have bad soils and poor soils, most times we use um, pile or even raft foundations, okay, like it's common in the islands in Lagos, okay, where you see a lot of piles, okay, pile foundations and raft foundations. Okay, now if that is correct, but on today we are only going to focus on how to design our shallow foundation, assuming soil bearing capacity of 150 kilonewton per meter square. Now within, if you are in Kaduna, most soil bearing capacity always falls within that range of 150 to 200 kilonewton per meter square, okay. Now if you agree with me, to start up our design, let me take you to our CAD viewer. This Schemata CAD viewer, you can download it, okay. We have done a lot of designs already on RCD 2000, on Orion, Prota Structure, Revit Architecture. If this is the first time you're viewing any of our videos, you can go down below the description of this video. You will see my our YouTube channel is there. You can visit that channel. You have all of those videos. We have more than 20 of them, okay, that we've done on RCD 2000. That is the best for beginners, okay. It opens your eyes to the reality of design, okay. Now on these, as you can see, we are using our phone, okay, so there is no barrier, there's no limit to what you can do with your phone, okay. To design our base, now you can see this is our CAD viewer, okay. We want to design base for these columns that are here, but we are only going to design a base for this column that we have designed already before. If this is the first video you are viewing, you can go down below the description. You have access to this video on columns, on slab, on beams, okay. Now the next thing we'll do, let's go to our okay, RCC spreadsheet, and we can begin our design. But now let me bring your mind to this. As you can see here, we said bearing pressure, as you can see here, is 42, right? which makes that soil a bad soil, okay, or a poor soil rather. When you come down here, you see it says exceeds permissible, exceeds 1.2 permissible. Okay, look at it, says base size suggestions. Now this is the base size that is suggesting for us. Now look at when you come up here. Okay, okay, it says enter data in blue cells only. So it is only data that are in blue cells that we enter. It said red messages indicate entry errors. Okay, so if there's a red message, that means there is an entry error. Okay, look at here, we have a red message, exceed permissible. Now that means we will have to come back here and change the size of our base. Okay, it has already suggested a size for us. Okay, it says we can use 2580 square, we can use 15 by, okay. Now I would suggest we use 2600, 26 by 26. Okay, if we use 26 by 26, 26 by 26. Now what do we have? Now let's come back here. Aha, you can see one of that information has actually disappeared. Okay, here let's change the depth of our base. Okay, let's make this 450 for example, and let's see what it gives us. Okay, it's still not okay. That means like I said, the soil is actually a very bad one, you can see. So it's advisable when you have a bad soil like this, maybe you use a raft foundation instead of a pad. Okay, we can go and we'll at the long run get what will serve, but it's better you use a raft. Okay, because that soil is actually mushy, it's actually very bad. Okay, so if that is correct, but here now on our design here, we are going to use 1000. Engineer, as an engineer, safety and economical should be your watchword. So your building can be safe, but it's not economical. Okay, if we use this value and change this bearing pressure to 150, you discover that it may be safe. Let's see what's giving us here. You can see that there is no red information. That means it's safe. Okay, but what this means is that this is actually what not economical at all. Okay, so your design should be safe and it should be economical. Okay, I'm changing the size of my base. Okay, you can see here, let me change this to let's see now let's see the information it will give to us. You can see there's no any red message. So our 1002 by 1002 base, I think it's okay, it's enough. It's enough. The depth too is okay. Our axial load, that is the load we actually got from our column. Okay, look at column reaction, kilonewton per meter. Okay, kilonewton meter characteristic. Okay, the axial load. Okay, that is the load from the column, the one we did in our calculation. Okay, I believe we remember where we did our loading from our column. You can see everything is relating to each other. We distributed our slab load down to our beam, we distributed our beam load to our column. Now we are taking our column load now to our base. Okay, you can see how these buildings how your building behave. Okay, you understand now how your building actually behaves. Okay, now if you change, this is the axial load to 222.7, approximately 223. Okay, your impulse load, this is not a constant value, please, you don't need to cram that. I would advise you get a reinforced concrete design book, either by Victor Oyenuga, by Mosley and Bongi, or you can get any other design book that is recommended. okay, maybe in your country. But if you are in Nigeria, I would advise you to get that of Victor Oyenuga. Okay, if that is correct, our design is correct. Our design is okay. There is no red message. There is no red message. Now, look at your concrete cover 50. You can change that. You can change, okay, the height of aggregate and all of that. All that is in blue cell can be edited. Okay, the size of column that is coming on it is 230 by 230 column. Okay, if it is more than that, you change the size. Okay, if it is a 300 by 300, you change. Now let's assume it's 300 now and change this to 300. Now let's see what it gives us. Let's see if this 1200 by 1200 will be okay, which I doubt. Okay, okay, okay. You can see the is suggesting our base, okay, which is still okay, still okay, still okay, still okay, still okay. So but our base, our column is actually 230 by 230. Okay, so if you like what you're seeing, why not give it a thumbs up? Subscribe to this channel. It's actually free. You see a red button down below the description of this video. Make sure you subscribe. You don't pay a dime for it. Okay, in the description box you see you can follow me on any of those social media platforms. You can chat me up on WhatsApp if you want to have this spreadsheet on your phone or on your system. You want to have some of our videos on your phones or on your system, we can send them to you, and then our um, Microsoft Word um, uh, uh, manual. You can have any of them on your system. Just chat me up and you can get it for a token. Okay, you can see the reinforcement that's provided. It says we should use Y12 at 150. Okay, spacing. Okay, you can see um for your breadth, which is 1002. Okay, on both sides you can see it is Y12 at 150 spacing. Okay, so that is it. I think our design is okay. Now when you look down below this, you will see single. You can switch it to double. For example, you are designing for combined base. Okay, if you are designing for a combined base, there are cases where you have a combined base, okay, when the columns are actually close to each other and then the base actually intersect each other. You tend to have a combined base, which will provide a doubly, the reinforcement will be doubly reinforced, that is your top and bottom. Okay, um, that is that. So but we are designing just a single base. You can flip through. You can see it's interesting. This is your graph, your legend, your notes and all of that. You can print this directly from your phone, okay, or you can send it to your system. Whatever that you are seeing in your phone, this is an Excel file. Okay, you can, it's the same thing, the same result. There is no difference with what you are doing on phone right now and what uh the result will give you even on your system is actually the same. There is no difference. Okay, all that is in your blue cell can be edited. You can change the made by, the date, the page number. Okay, you can include the name of the client, the name of the project. Okay, you can see this is reinforced concrete base type 1. You can change it to maybe base type 2 to base type 3, because you may have different types of base in a particular building. Okay, you can have different sizes of base, different types of bass. You can have a combined, you can have a single bass, and all of that. Okay, if you love what you have been watching, make sure you give it a thumbs up. Subscribe to this YouTube channel. It's actually free, you don't pay a dime. Okay, and then leave a comment down below. Okay, because this is actually amazing what you can do with your phone. Okay, leave a comment down below so as to encourage us, and so as for us to know how we can help you. Okay, thank you very much, and you stay blessed.